Boiler heating systems. In this presentation, we're going to be looking at the different types of heating energy that are used in a boiler system, different types of boiler applications, circulation pumps for boilers, flame ignition and flame proving in a boiler system control, and finally, zone valves. First off, different types of energy. We have natural gas or propane fired boilers, heating oil powered boilers, or electric powered boilers. When we look at a residential type of boiler system, it's rather small, and there are a lot of plumbing connections to it, as the purpose of a boiler is to heat water. In an institutional or industrial setting, the same thing is true, however, it is much larger. Boilers are used for both the cooling and the heating in large industrial and institutional settings. And the systems that we're going to look at in this presentation can easily transfer outside of the residential field. Generally speaking, a boiler is going to cause a significant amount of heat to be produced in a burn chamber, which will then transfer through combustion gases heat to a tube which has water inside it. The water is then heated to a predetermined level and then either circulated or just gravity fed through a pipe to something called a heat exchanger or radiator, which then transfers the heat from the liquid to the air or another surface. Boiler system use and design. There are many different applications for boilers. They can be used for domestic hot water, as in the water we use for showering and bathing. It can be used to heat the room through a radiator or baseboard. It can be used to heat a floor. It can be used for different types of snow and ice melting in colder climates. It can also be used in areas where we have car washes, and not to mention, it can be used as a means of forced air heating by passing forced air from a fan across a radiator section. There are two basic varieties of boiler systems. One is referred to as a gravity system and the other a forced circulation system. We are going to focus on the forced circulation system as it is more prevalent in industry and requires use of an electrician when it comes to the controls. The devices connected into the boiler system which transfer heat from the liquid are referred to as heat exchangers, and there's a number of different ways that these can be constructed: baseboard, hanging forced air, or in-floor pipes. Let's take a look at each one. A baseboard would be the type that most of us are used to, and it simply looks like a radiator that has a cover over top of it. Often it doesn't look much different from an electric baseboard heater. This is what one end of it could look like. And again, you can see the fins on it, which are used to transfer the heat energy from the hot liquid inside the pipe to the surrounding air around it. A hanging forced air system is used where we have the hot water passing through a radiator, and then we blow air across it in much the same way that a furnace would operate. Even more common is in-floor heating, and this is where plastic water piping is then embedded in the concrete slab or just below a finished floor. And the heating of that water inside the pipe then transfers to the slab and heats the floor. This is often considered to be one of the more efficient means because the heat rises throughout the room, and the floor that people are in contact with, that they have touch with, is warm. And so most people feel warmer in a room with in-floor heating as opposed to forced air heating. There is one downside of in-floor heating, and that is that it takes a long time to change the temperature. It can take several hours, even days, to change the temperature of a concrete slab 5 degrees centigrade. So this is often used in residential, in bathrooms where a tile floor is utilized, and in commercial installations where we need snow melt. This is what it could look like prior to the concrete being applied on top. Boiler circulation pumps. Boiler circulation pumps are a specially designed pump that's intended to be used with a very hot fluid. They move water from the boiler through pipes to the desired location, and at times they can be built into the boiler or a separate installed device. They're typically single phase, and most are capacitor run. This allows for them to be highly efficient and also very quiet. It's very interesting when working with boiler circulation pumps because of their unique design. This is essentially what we have for parts. There's something called the power head, which is the motor stator, the terminal connection box, and the capacitor. There is then the motor rotor, which is removable and replaceable and permanently connected to the pump impeller. And then there is the pump housing. All three of these items can be replaced independently and are intended to be replaced as their serviceable life reaches an end. A boiler circulation pump will have a interior rotor that can easily and normally be designed to be removed from the power head, which is far different from any of the other types of motors that an electrician will commonly encounter. Flame ignition and flame proving. Boilers can be conventional, mid, or high efficiency, and they have very similar components as what is seen in a forced air heating system. The burner flame is again ignited by either standing pilot, DSI, or HSI, depending on its efficiency value. We have thermocouple, flame rod, and pyrostat, which can all be used to prove that a flame is present in a boiler system. Now, at times, pyrostat is a little more common, and it's a bit of a different type of device. It looks very similar to a fan high limit switch that we would expect in a furnace, but instead this one is actually mounted in the flue. Now the flue is the area where the exhaust combustion gases pass through, and the entire purpose of the pyrostat is to simply sense when the heat value increases. When the heat increases in the combustion gases, that would mean that the flame is present, and it could then prove to the system to allow for the main gas valve to be opened. Another means of providing flame proving is through a CAD cell. And a CAD cell is simply a light activated device. And it's sensitive so that when it sees the light of a flame inside the burn chamber, it will then send a signal back to the boiler itself. Boiler system control. Boiler operation is very similar to forced air heating system operation. And what that means is that in a standard forced air heating system that is mid or high efficient, we have a call for heat from the thermostat, combustion fan turns on, flame ignites, flame proven, heat exchanger temperature rises, the fan set point is reached, the fan switch closes, which then turns the blower on, and hot air travels through the duct system. In a boiler, we would have the same operation, a call for heat from the thermostat. Combustion fan would turn on inside the boiler system. The flame would ignite, the flame would be proven. The heat exchanger temperature would increase, and finally, the water set point would be reached, and the water set point switch would close. Then the circulation pump would turn on, and hot water would travel through the pipes. Now, for a heating cycle on a forced air furnace, we would use terminals R and W on both the furnace and the thermostat. In a boiler heating system, we use the same two terminals on the thermostat, and the boiler will have an R and a W terminal to terminate the wires too. In furnaces, we have a temperature sensing device that measures the air temperature in the plenum, and we call this the high limit and fan on or off system. In a boiler, we have the same type of application, but in something called an aquastat. And an aquastat is simply something that measures temperature of water. We have immersion aquastats, which are intended to be actually immersed around the interior water of the boiler system. And we have surface mount aquastats, which are really no different from any other type of temperature sensing switch. In this case, they are strapped very securely to the outgoing pipe of the boiler system. Now, boilers typically have two aquastats. One of them is a high limit, which would tell us to shut down the boiler if the water temperature got far too high. And in this way, it's a safety type of device. The other aquastat we have is called a circulator aquastat. And at times you'll hear it referred to as a reverse acting. And this is what tells the circulation pump to turn on or off. The circulation aquastat will turn on the circulation pump when the heat gets too hot or when the heat reaches the point that we require for operation. So it's normally open and it closes on heat rise. A high limit aquastat is normally closed and will open if the heat in the water is exceeding the value that is safe for the operation. This is an example of a boiler combination aquastat that has both the settings in one apparatus. Here's an example of a basic control schematic for a basic boiler system. We have two separate aquastats, a circulator and a high limit. The circulator is controlling the circulating pump. The high limit is controlling the gas valve. The thermostat, in this situation, controls a relay coil which closes a set of contacts both in the gas valve and in the circulation pump circuit. This is a more appropriate diagram showing the actual wiring that would be required on a typical boiler. Again, it's very similar in nature to a basic furnace in that it's not quite a schematic and it's not quite a wiring diagram. There is one connection for the aquastat, which would control our different type of circulation pump. Inside a furnace, or inside a boiler rather, the presence of water is very important. If there's no water inside the boiler, the heat exchanger could be damaged. And so to prevent this from happening, often there is a low water cutoff switch, which again should shut off the boiler if the water level drops below a predetermined level. Here's where the low water cutoff would typically be connected. Small boiler system control. Well, we already know that a thermostat is used in the same way as what we would see in a furnace. We would have a low voltage wire that would connect the thermostat back to the boiler, and we would use terminals R and W. Now, of course, a standard thermostat has more than just R and W, and so those Y and G terminals would simply not be used if we were connecting to a boiler. And on the boiler itself, the only terminals that we would expect to be utilizing are R, W, and C. There are many different arrangements of boiler system operation. We could have one where one thermostat controls one circulation pump and the boiler for the entire house. In this way, we may have a continuously operating circulation pump, and the pump remains on at all times, and the thermostat then decides when the gas valve is energized to heat the water. This is simply one example of many different types of system designs. We could also have an intermittent operation circulation pump, which is the one that we looked at previously, where we have our aquastat that is turning on the circulating pump when the temperature has been reached. What is more common when working with boiler systems is to have individual control over different areas. These different areas are then referred to as zones. This way, we can have multiple thermostats controlling multiple rooms and only turning on the boiler and causing hot water to flow into the area that we need an elevated temperature. The thermostats in these systems typically do not energize the boiler themselves, but they energize a zone valve. The boiler is then turned on and off by either the zone valve or flow switches. So let's see how this would work. So here's our boiler. We got a circulation pump, and we have all of these different zones, and each one having its own thermostat. In order to control these zones, we need to use what's called a zone valve. Now, a zone valve is slightly different than the valves that we're used to in electrical, and it's because they are very slow opening. This prevents pressure waves from echoing through the boiler system or water hammer and damaging components. A standard fast-moving solenoid valve, like seen in industrial applications, is not used in a boiler system. Here is an example of what we could expect on a boiler system ball valve. Inside this zone valve, we can really separate it into two separate items. There's the electrical actuator and the valve body itself. And it's very common to replace the electrical actuator without removing the valve from the boiler system. Here are how the two separate, and you can see the ball valve inside. The ball valve is operated by rotation. And this is what the assembly would look like without the electrical actuator on top. It operates by swiveling the ball left or right into either an open or a closed position, preventing flow through the pipe. Inside the electrical actuator is a series of different electrical apparatus, including a very small micro switch, an electric motor, and a reduction gearbox. So if we were to open it up further, we would see this, a motor and a gearbox to reduce the speed.
Now we'll go ahead and power it. So you can see the sprocket right there moves very, very slowly.
So the actuator itself, through the very slow rotation of that gear, will turn the valve and close it slowly. Most zone valves will have a manual override switch to open or close the valve, depending on what is required. Now, there are literally hundreds of different brands, series, and versions of zone valves, and we're not going to look at every single one of them. Instead, we're just looking at the very basic common features that we should be aware of if we are working with a zone valve in a boiler system. Here's an example with multiple zones and multiple circulation pumps, and a system with one circulation pump and multiple zone valves. Common zone valves come in three different varieties: 2-wire, 3-wire, and 4-wire. Let's take a look briefly at what the difference is between them. 2-wire are the simplest to consider the operation of. They simply mean that when energized, they will open or they will close depending on how the system has been set up. So there's a small transformer that provides power, and the thermostat is used to then control the zone valve. When the zone valve opens, it allows hot water to flow through that zone and increase the heat of the room. Eventually, the wall thermostat registers that heat and opens, and the zone valve closes. For this particular operation, we would need a continually operating circulation pump. 3 and 4-wire zone valves are slightly different, and they utilize what's called an end of travel switch. An end of travel switch is essentially a micro switch, which will close after the valve is fully opened. And you can see it identified there in the dotted line box or circle. The small lever that we see here will slowly push on the micro switch and depress it fully when the gearbox has finally opened the valve completely. So what we could look at for the contact in the micro switch is that when the zone valve is energized, the contact closes. And when the zone valve is de-energized, the contact opens.
So you see our motor's turning, which makes our gear turn, and the tab is going to press up against the micro switch, and you're going to hear a clicking noise. That means that the two red wires are now touching, and that's an indication that the valve is actually open. Now let's go ahead and disconnect our power. Now you heard that click, which means that the two red wires are not touching, and now our valve is closed.
In a three-wire system, not only are we powering the zone valve itself, but we also have a contact that can be utilized. And that contact can then be used to turn on and off the boiler in the same way that a thermostat would have previously. So here's a zone valve that is three-wire. We again have a transformer that's providing power, but notice this time they've chosen to use a 120 volt. It's a little bit different, coming down and operating our zone valves down to 24. The thermostat, a standard low voltage thermostat, is used again to energize the zone valve, and when the zone valve is fully open, the switch closes, or the micro switch. Now, if we take a look at where that connects back to, it actually energizes a relay coil. And the relay coil controls a set of normally open contacts. The normally open contacts go all the way back to the R and W connection on the boiler itself. And what that does is when this contact closes, it connects these two terminals in the same way that a thermostat would have, and it causes the boiler to go into a heating cycle. Finally, a four-wire system operates in much the same way, but without a common connection between the micro switch and the valve motor itself. In this system, again, our wall thermostat is used to operate the zone valve, which is this rectangular sort of boxy device that this manufacturer chooses to represent their valve with. And when it is fully open, the switch closes. When the switch closes, there's no need for an additional relay because, again, it connects back to R and W on the boiler, and that causes, just like a thermostat, the introduction or the start of a boiler heating cycle. There are hundreds of different designs of boiler controls. What is important is that we understand how zone valves are utilized and what the wires connect to. We have micro switches and we have the actual valve itself. What is not important is to try to memorize every single schematic that could possibly be used for boiler control. As an electrician, you should be aware of general concepts, and when given a design, extrapolate how it should function, not memorize every single possible variation.